We're going to talk about the blood. We're going to talk about shock, and then we're going to talk about different types of shock. Our blood has three functions. Transportation of oxygen and nutrients to and from the cells, to bring oxygen and nutrients to the cell, and take waste away from the cells. Regulation of the body's pH, and one of the blood's functions is to regulate homeostasis in the body. Remember, homeostasis is that it's all good, everything's nice and equal. Alright? There are buffers in the blood that are there to regulate the pH of the body. We'll talk about that in just a second. And then the blood also serves protection. The blood contains cells which fight off infection. And I'm sure you are experiencing right now. You should thank your white blood cells.
I'm trying to piss me off actually. It ain't helping.
Don't turn it. That's what we'll do. Instead of me just wondering, I'll just flip it and y'all just holler if I need to flip it back. And then after we're done with this tonight, I will give you a copy of the slides.
When you pull up that article on, it was called tinnitus? Tinnitus. Is that an indication of permanent damage?
Not necessarily.
Not necessarily?
If you're worried, guess who got it?
No.
You got some tinnitus?
Well, I mean, I was sitting in my house today. It rang once, 5 seconds later, it rang again. I was walking from my car, it rang again. About 5 times a day. A little more frequent than all.
Mine is just caffeine.
Caffeine?
Yeah, if I have caffeine, mine is so bad.
Stop taking shots to the head.
What?
Stop taking shots to the head. And go by better eye, better mouth guard. Do a double mouth guard. Do that too. Don't be pushing in the ear.
Yeah. Alright. So we just talked about the three functions of your blood. Now I want to discuss the components of your blood that carry out those functions. First of all, you have the plasma, which is the liquid portion of your blood. Inside the plasma, we have everything else, including the erythrocytes. Those are your red blood cells. The red blood cells are the ones that carry oxygen and carbon dioxide. We have leukocytes, which are your white blood cells. They are the ones which fight infection. We have hemoglobin, which is a protein, and that protein is used to bind the oxygen to the red blood cells. We have hematocrit, which is a measurement. It's not actually a component, it's a measurement. Hematocrit is the volume percentage of red blood cells in whole blood. Does that make sense? For instance, if I had, I need to buy my own markers. If we had a vial of blood, right, and there's blood, and in that blood, in that tube, now they put it in the centrifuge and spin it around real fast, and all the red blood cells go to the bottom, and it's 50% of the total volume, then that could be 50. Does that make sense? And then finally we have platelets. Platelets are the elements in your blood which promote clotting. Alright. Also in your blood are antigens, antibodies, and RH factors. Those aren't really parts of the blood, those are attributes of the blood. An antigen is a protein that triggers the formation of antibodies. Your antibody is a protein developed in response to an antigen. Okay, so an antigen is a marker, if you will, and the antibody is a protein that your body develops in response to that marker. That is where you get your different blood types from. Like there's antigen A and antigen B. So if your blood cells have the A antigen, you have type A blood. If they have the B antigen, then you have type B blood. If you have both antigens, you have type AB blood. And if you have no antigens, then you have type O blood.
Yeah. What's the significance there? I mean, is it one superior to another?
No, one is not superior to the other, but they are different from each other as far as those antigens go. It's the same cells, they're just marked differently. And what that is, it makes it unique for your body. And so when you receive a blood transfusion, for example, you have to receive blood that has the same antigens in it, or your body won't accept it, and it causes a lot of problems.
You know, I'm already in trouble because I got the rare type.
Deal?
Oh, Dave.
I will be negative.
That's pretty rare too.
Oh,
Too much into the blood types, because that's really beyond what we need to discuss for here. You also have the RH factor. That's where you get your positive and negative. Are you the RH positive or RH negative? That's where you get type A positive, type A negative, O positive, O negative, so on and so forth. We're discussing Cliff running from the cheese monster, and I said that one day that would be important. Well, that day is today. For now, we break into acid-base balance.
we have a recap on the cheese monsters.
It all makes sense in just a minute. It'll be okay. Alright. First of all, what is pH? pH stands for potential of hydrogen. Alright, basically it measures how acidic something is. pH is measured on a 14-point scale from 0 to 14, with 0 being the most acidic and 14 being the most basic. 7 is in the middle, is considered neutral. Alright? For example, distilled water is neutral. Distilled water is right in the middle at 7, whereas hydrochloric acid is 0, and sodium hydroxide is 14. And the pH of your body is between 7.35 and 7.45. I write that number down, it's very important.
7.35, 7.4.
Okay, 7.35 to 7.45. The scary thing is, once you start learning all this stuff, and you realize on what a narrow window we're alive, it's kind of scary. Anything outside of that number puts you in real trouble. So an acid is anything with a pH of less than 7, and a base is anything with a pH greater than 7. Is that okay? Are you good? All right. Remember on that first slide, when I told you one of the functions of your blood was regulation, right? So I want to work to use regulation, regulation of the pH in your body. And that's accomplished through buffers. All right, there are substances in your blood called buffers. And what buffers are is they are fast-acting defenses which act in response to a rapid change in the body's pH. What they do is they absorb hydrogen ions whenever they are in excess. Right? So if you have an excessive amount of hydrogen ions, what would that make your blood?
Acidic.
Acidic, yes. All right. So they will absorb hydrogen ions whenever there's too much acid, and they will also release hydrogen ions whenever there's too low. All right. It works to keep it at that 7.35 to 7.45. Your body does this in many different ways. The major buffer in your body is the carbonic acid system. Okay? You have this chemical right here, H2CO3. Now, H2CO3, you can pause the tape, this will take a minute.